Hi guys, welcome back to my YouTube channel. Today in this video we are going to learn about process models in software engineering. Process models in software engineering are structured frameworks that outline the phase and activities involved in development of software. They serve as blueprints for managing projects, ensuring consistency and promoting collaboration among themselves. Understanding these models is essential for project managers, developers, and stakeholders to align expectations, track progress, and deliver high quality software solutions. Waterfall model. The waterfall model is a sequential approach where each phase of development must be completed before moving to the next phase. It emphasizes a structured and disciplined methodology with a clear separation of tasks like requirement gathering, design, implementation, testing, and deployment. This model is suitable for projects with well-defined requirements in minimal changes through the development cycle. However, it can be rigid and less adaptable to evolving needs. Requirement gathering. The initial phase focus on understanding and documenting the user needs, expectations, and functionalities of the software. Design. The design phase translates the requirements into a detailed architecture plan outlining the software structure, components, and interactions. Implementation. This phase involves coding and developing the software based on approved design specialties. Developers write code, build the software, and test its functionalities. Testing. Once the software is built, it undergoes rigorous testing to identify and fix defects, ensuring the software meets the quality standards. Iterative model. The iterative model adapts cyclic approach, breaking down the development process into smaller iterations or cycles. Each iterative involves planning, designing, implementing, and testing a subset of features, allowing for early feedback and adjustments. This model's flexibility and adaptability, enabling teams to respond to change require and emerging technologies. It is well suited for projects with evolving needs or where early users' feedback is critical. Initial iteration. The first iteration focuses on developing a core set of features, providing a working prototype for user feedback and validation. Subsequent iterations. Each iteration builds upon the previous one, incorporating feedback, adding new features, and reflect existing ones. This iterative process allows for continuous improvement and adaptation through the development cycle. Final iteration. The final iteration delivers a full functional and tested product, incorporated all the features and enhanced development during the previous iterations. Spiral model. The spiral model combines eliminations of both waterfall model and iterative model, empathize risk management and iterative development. It progresses through a series of cycles, each encompasses planning, risk analysis, and engineering of evolution. The model allows for continuous assessment of risk, enabling teams provide address and potential issues early in the development process. This approach is particularly benefits for large complexity projects with high uncertainty where risk need careful management. Planning. Each cycle begins with planning, defining goals, scope, and resourcing to the particular iteration. Risk analysis. Risk assessment is a critical aspect of each cycle, identifying potential problems, evaluating them impact, and developing mitigation strategies. Engineering. The phase involves developing and implementing the software components, incorporated feedback from the previous cycles, and addressing identifying risk. Agile methodologies. Agile methodologies empathize iterative development, customer collaboration, and continuous improvement. The, they promote flexibility and adaptability, allowing teams to respond to changing requirements and deliver value in increment steps. Key principles include embracing cycle, focusing on user value, and working in short iterative cycles. Agile practices have gained popularity in software development, enabling teams to deliver software faster, adapt to changing conditions, and improve customer satisfaction. Customer collaboration. Agile methodologies prioritize continuous collaboration with customer gathering feedback and incorporating their input through the development process. Iterative development. The development process is broken down into short iterations known as sprints, allowing for rapid promoting, testing, and feedback loops. Continuous improvement. Agile teams embrace a crucial of functions, improving, reflect on their work, identifying areas for enhancement, and reflecting their process. Flexibility and adaptability. Agile methodologies are high adaptable, allowing teams to respond to changing requirements and prioritize most valuable features. Scrum. Scrum is a popular Agile framework that provides a structured process for managing complex projects. It divides the development process into short iterative cycles as sprints. Scrum empathizes self-organization teams, daily stand-up meetings, and regular sprints. And the key role of Scrum is include a product owner, Scrum master, and development team. Product owner. The product owner represents the voice of the customer, prioritizing features and ensuring the development team aligns with product vision. Scrum Master. The Scrum Master facilitates the Scrum process, guides the team, removes independence, and ensures the team development team. The development team consists of cross-functionalities professionals who work together to build and deliver software increment. Kanban. Kanban is a visual system that managing work empathize continuously flow and increment delivery. It utilizes a broad with columns representing different stages of work such as to do, in progress, and done. Tasks are represented by cards that move across the board as the process of working. KNAB empathizes visual representation, continuous improvement, and limiting working progress to optimize efficient and reduce bottlenecks. Tasks are represented by cards, each representing a specific piece of work that needs to be completed. Workflow. The workflow is visualization through the columns on the board representing different stages of the task lifecycle. WIP limitations. KNAB uses WIP limitations to restrict number of tasks in progress at any given time, preventing bottlenecks and improving workflow efficiency. Continuous development. KNAB emphasizes continuous improvement, encouraging teams to identify areas of optimize and refine their workflow. DevOps is a critical and technical approach that aims to break down between development operations teams. It emphasizes collaboration, automation, and continuous delivery to accelerate software development and improve the overall software. DevOps practices involved into enabling seamless communication, integration, and deployment of software, focusing on shared responsibility development. The development team build and test software, focusing on creating new features and functionalities. Operations. The operations team manages the infrastructure development and monitoring the software, ensuring its stability and performance. Collaboration. Development DevOps encourage close collaboration between development and operation teams, focusing on communication and shared ownership. Automation. Automation plays a crucial role in DevOps, automating tasks such as build, test, development, and monitoring to reduce manual effort and improve efficiency. Continuous integration and development. Continuous integration and continuous deployment are key practices with DevOps that aim to automate the software pipeline. C involves frequency, integrity, code changes into shared repositories, trigger automated builds and tests. CD automatically deploys changes to product environment after successful builds and tests, enabling faster release cycles and reduce the risk of errors. These practically enhance software quality and accelerate delivery and improve overall efficiency. Code changes. Developers make code changes and commit them to a shared repository. Continuous integration. The code changes are automatically integrated into shared repository, triggering automatic build and test. Automated testing. Automated tests are run to ensure the code changes doesn't introduce new bugs or resistance. Continuous development. If the test passes, the code changes are automatically deployed to product environments. Monitoring the feedback. The software is monitored in product and feedback from the users. and operations terms in used of future release. Conclusion and key takeaways. Process models plays a crucial role in software engineering, providing framework for management projects, ensuring quality and delivering values to users. Understanding the different methods, their strengths and weakness is essential for choosing the most appropriate approach for given project from traditional methodologies like the waterfall model, agile model like Scrum and KNAB, the evolving practice of DevOps and CI/CD. The software development landscape is constantly evolving, with each model offering unique benefits and changes. Thank you for your valuable time.